Hello and welcome to the first session on organic chemistry. Organic chemistry for the ATA syllabus, it has got parts that are similar for year 11 and year 12. Basic organic chemistry, if you're doing year 11 at this stage, it will come back again when you are doing year 12 chemistry or unit 3 and 4. But basically, that will be unit 4 because the whole of unit 4 is mainly organic chemistry. Right, without wasting much time, let's just quickly take a look at the session outcomes. One of the things I'll be expecting you to understand by this end of the session is the fact that the study of organic when we're studying organic chemistry, we're studying carbon-based compounds, and we should be able to describe the bonding capacity of carbon and how it's really essential in the formation of carbon-based compounds. We are also going to look at explaining the diversity of carbon-based compounds because there's plenty of them out there. So what we're doing for this first part in year 11 is getting you to recall some of the things you did in year 10 and adding a little bit more as we build your muscle in this area of trying to understand carbon chemistry. I'm also going to get you to recall that organic compounds are grouped in order for us to be able to study them much easier. Because you can imagine if you've got a lot of objects, of course, some of these objects might have something in common, but they've got some unique properties or characteristics that they have. It will be easier to put them in specific groups and then you study them. And where there are crossovers in terms of similarities of properties and behaviors and characteristics, then it will make your life a lot easier because you can actually identify where these similarities and differences are when you group all the objects that you're trying to study. The same thing with organic chemistry. They are actually grouped into compounds with similar characteristics so that it can be easy for us to study them. Now, so what is organic chemistry basically? Organic chemistry is the study of all carbon-based compounds except carbonates, hydrogen carbonates, and oxides of carbon. Okay, what do we mean by carbonates? Your carbonates, you're looking at things like substances like potassium carbonate. When we are looking at hydrogen carbonates, we know the hydrogen carbonate ion from what we have done so far looks something like this. So it could also be magnesium or calcium hydrogen carbonate. This one here these are actually classified as salts. They are not organic compounds. And oxides of carbon, we have got two that we know, carbon dioxide and carbon monoxide. These two are not organic compounds. So anything that has got a name carbonate or hydrogen carbonate or it's carbon dioxide, carbon monoxide, it doesn't qualify as an organic compound. Now, moving on, like I said earlier, this is the first split or the first grouping that takes place here. We split these into hydrocarbons and derivatives of hydrocarbons. Probably the word derivative might throw off some of you guys. You might not understand what it means. It means something that has been made from hydrocarbons. So the compounds, these carbon-based compounds that we study are split into two groups, which is the hydrocarbons. The hydrocarbons are all compounds that are only made up of carbon and hydrogen. And derivatives of hydrocarbons will have carbon, hydrogen, and any other element in that structure. But as long that element doesn't make that compound to be hydrogen carbonate or an oxide of carbon, then it's still an organic compound. So we've got two groups of organic compounds, major ones, which are the hydrocarbons and their derivatives, which is what is born out of these hydrocarbons, what we make out of hydrocarbons. So if I've got a certain hydrocarbon, I can add other elements on that hydrocarbon to make it look different, and we call that a derivative of, because it has been derived, it has been born out of, it has been made out of the basic hydrocarbons that we know of. Okay, moving on, hydrocarbons, like I said earlier, for you to get something to write in it, these are compounds made up of only hydrogen and carbon, which means if I've got a compound, an organic compound that is made up of carbon, hydrogen, and oxygen, that's no longer a hydrocarbon. If I've got an organic compound that is made up of carbon, hydrogen, and nitrogen, that is no longer an organic compound. If I've got a compound that is made up of carbon, hydrogen, and oxygen, that's no longer a hydrocarbon. It's actually a derivative of a hydrocarbon, because to the CH, now what have we done? We have added an oxygen. Here we've added a nitrogen, and over there we've added a nitrogen and oxygen to the CH. So basically these are examples here of your derivatives, but we're going to go into the details of this. For your own information, some of these derivatives might be mentioned as we study basic organic chemistry. The derivatives of hydrocarbons are actually studied in Unit 4 of your Year 12 course. That is for the WA curriculum. You might be watching this and you're not doing the WA curriculum. You might be studying this at a different stage, but this is mainly focusing on the WA curriculum, Western Australian curriculum. Now, let's move on. Hydrocarbons are further classified into these families. We've got alkanes, alkenes, and alkynes. Alkynes are not studied at this level. There isn't much chemistry on alkynes, but we don't study them. And you can see there's another family which we call cycloalkanes. Cyclo simply means it's an alkane which is in a ring, which means we turn that into a ring. Cycloalkenes, it means it's an alkene that is made into a ring. And we've got aromatics. So for year 11, we're going to look into the details of what all these are. That's what our focus is on. And for our aromatics, we'll be looking at benzene and toluene only, nothing much on aromatics. That's what we're going to be focusing on at this stage. So basically, this is just an overview, guys. Don't worry if you don't know what an alkane, alkyne, cycloalkane is. We're going to study those in detail. This is just an overview of what organic chemistry is all about. Let's take a closer look at carbon. Carbon is a very unique compound. I know some of you might know other compounds that are able to bond with each other and form, some short chains or networking of some sort, like, sulfur, oxygen, those kinds of elements. But carbon is very unique. Carbon is capable of forming chains, which means I can join as many carbon atoms as I want, and it remains stable. So this chain here will form what we call the backbone. Right, like you can see, this is like a skeleton. We've got a skeleton inside there. Obviously, the outside is showing the flesh and the body, the rest of the body. But you can see that our body is actually supported by this structure here. This is the backbone. Okay. Same with organic compounds. Organic compounds have got a backbone, and this backbone of organic compounds is made up of carbon atoms, and from the carbon atoms everything else comes out of there and it hangs off this backbone. And for this to happen, this backbone must be stable. Okay, so carbon is a unique compound. One, we know that carbon is in group 4 from what we did when we looked at bonding and atomic structure. The periodic table looks something like this, and carbon is in group 4. This will be group 14, this will be group 13, this will be group 14. Carbon is in group 14 right there. And because it's in group 14, carbon is capable of forming four covalent bonds. And with this, within these four covalent bonds, it can actually combine with other carbons to form a chain. And this chain can either be a straight chain or it can be a ring. We can have carbons like that joined together into that kind of a chain, which is cyclic. This is where the prefix you were seeing earlier, cyclo, comes from. This is a cycloalkane because we've got three carbons that are actually bonded in a ring, and as a result we call it a cyclic hydrocarbon. Now, so that you get something to write down, let's go through a few bullet points here that I've got. Like I said, carbon is a unique element because it is capable of forming long stable chains. It depends really. Using the word long here, I'm just trying to say it can go from 1 all the way up to as many as 20, 30, 40, 50. It doesn't really matter. So and the chain remains stable, which means it can support other things around it. Like this backbone here, it is made up of about 32 bonds, right? These 32 tiny bonds there, they have to be really stable to be able to sustain and hold everything that is hanging off this backbone and maintain that person moving around without things falling apart. So that's what I mean by stable. Another thing here is the chain acts as a backbone of all carbon compounds, like I said, and the chain can be straight or cyclic. This is an example of a four carbon chain, and it can be represented this way as well, whereby I can use these lines where at the end of each line there is a carbon, right? So this one here has got 1, 2, 3, 4, 5, and this one has got 4 chains. And if I'm to make a derivative, let's say at the end of the chain, or on each of these, I can complete the 4 bonds of carbon using hydrogens. Same here, I can add hydrogens there to complete the 4 bonds of each carbon, and this becomes a hydrocarbon. But if I replace one of the hydrogens with something else, it's no longer a hydrocarbon, it's now a derivative of a hydrocarbon. So we're going to look at that later. Like I said, if you study chemistry in year 12, unit 4, that's where you're going to be focusing on these derivatives of hydrocarbons. Another example here I've got is, you can see this cyclic form. I've got 1, 2, 3, 4, 5, 6, and we can complete the bonds here with hydrogens, which means I can add 2 hydrogens on each carbon so that each carbon has got 4 bonds, which completes its bonding. And this is like a skeleton similar to that one here of the same element. This and that are just the same. Let's move on. The shortest backbone has 1 carbon, so which means I can only have 1 carbon, just like if I could have a living organism which has got only 1 vertebral column, which is one of these small bones, right? It can only have 1. Some have got 32. If you take an elephant, might have more, and will have more. If you take a giraffe, it will have even more than an elephant, more than a human being, because it will have a very long backbone, a very long structure. So these carbons can vary from 1 all the way up to, like I said, the most functional ones which are known, which I can tell you, for example, of things that you can associate with, are the chains that make soap. Soap is made up of chains that have got up to between 17 and 20 carbons in the chain. So the soap we use every time for washing, for cleaning, or detergents, they've got these many carbons in their chain. If you look at oils and fats have got like the same number of carbons in their chains as well. So basically these carbons can vary from 1 all the way up to 50, 100, or whatever it is, as far as the hydrocarbons that are known to us. Okay, Let's try out an exercise here, guys, so that we can see if you remember some of the things that I've been discussing with you. Which of the following are not organic compounds? So what I want you to do, guys, is you pause and you actually try and then you check your answers. That's what this PTC means here. Pause, try, and check your answers. Is this one here an organic compound? I'll leave you to pause that. I'm hoping that you're pausing this. I'll just continue so that we have a flow in this video and also to save time. This one here is sodium carbonate. So because it's a carbonate, so it's not an organic compound. Let's look at the next example that I've got. I've got this one here, carbon dioxide. This one here is an oxide of carbon, so it's not an organic compound. Please pause the videos and try out before you actually look at the answers. Let's look at the next one. I'll give you a chance to pause. Right, you can try it out and then come back when you've finished. This one here is not a carbonate. It's not an oxide of carbon. This is actually carbonic acid. Carbonic acid is an organic compound. This is organic. Okay, let's look at the next one. The next one is this one here. You don't need to know the name, but just look at it. Would you, of all the carbonates you have studied, does this look like a carbonate? No, it is made up of carbon. It's not an oxide of carbon. So where would you classify? How would you classify? Where would you check this? I would check this as well. That under organic compounds, it's also an organic compound, that one. Let's look at if I've got the next one. Yep, I've got another one here. This one here, we've been dealing with this from the start of the year. You must have been dealing with this from the start of the year when you did acids and bases. It's one of the organic acids that you've been told, because this one here is made up of carbon, hydrogen. Even though we've got oxygen there, it's not an oxide of oxygen, so of carbon. So this one here, sorry, it said oxide of oxygen. It's not an oxide of carbon. So this one here is also an organic compound. Now, let's move on. This one here is another example of an organic compound, which is basically a hydrocarbon because it's only made up of carbon and hydrogen. It's not a carbonate, it's not an oxide or hydrogen carbonate, right? And this one here, it's sodium hydrogen carbonate. This one here is not an organic compound because it's a hydrogen carbonate. It belongs to the family of compounds called hydrogen carbonates, and it's a salt, so it doesn't qualify as an organic compound. This one here is one of the organic compounds you come across in year 12. It's called a triester. This is how fats or oils look like, depending, but anyway, we're not going to go into the details of that. But it's an organic compound as well because it's only made up of carbon and hydrogen. So by the end of the topic by the end of this whole unit or chapter in organic chemistry, you'll be able to know the following. These are the important things we're going to understand by the end of this. Would know the major functional group, the general formula, how the structure, how to draw them. I've just shown you a few structures there. Nomenclature, this is another special or fancy word for naming compounds. Properties, which is the physical and chemical properties. Physical, like boiling point, melting point. How do those properties change from one family of hydrocarbons to the next, and how they behave chemically, which means how they interact with other chemicals, forming new materials. Isomerism, it means a different way of arranging the same atoms but maintaining the same number of atoms and types of atoms in the compound. And this one here, distinguish functional groups using reactions. This is a way of telling if I've got two organic compounds, say hydrocarbons, how do you tell them apart using chemical reactions. And basic organic chemistry, like the one you're going to be looking at, like I said, you're going to be focusing on hydrocarbons. We'll study alkanes, alkenes, aromatics, And these alkanes and alkenes can be classified into straight chain and cyclic. That's what we're going to be looking at in detail. This is just to give you an overview of what's coming. And this leads us to the next session, where we are going to be looking at the following outcomes. And it brings us to the end of this first session on organic chemistry. I'll see you when we cover these next outcomes.